Okay, we're going to explore sine law and cosine law. First of all, here's a version of cosine law, and this is technically a version of sine law. Okay, we're going to be using both of them. Now, in order to understand them, we do have to relate them to a triangle. Okay. First of all, sine law can be written like this, or it can be written flipped upside down, because technically it is a ratio. So I could write it as A over sine A, as long as I flip the rest of the ratio, B over sine B, and C over sine C. Okay? Both are legit. It's completely up to you how you would like to memorize or write it. Both are completely fine. Now, when they talk about sine uppercase letters, those are the angles. Okay, so in sine law, it's sine, that angle, that angle, that angle. And the lowercase letters are the sides. Okay, and in reference to each other, wherever the angle is, say this is called angle A, then the opposite side must be A. And vice versa. If this is side B, well, the opposite angle must be angle B. Okay, that's important to know. Now, cosine law. They'll write this many different ways. I suggest just to memorize one version. This one here, which says side C squared is equal to side A squared plus B squared minus 2 times side A times side B times cos angle C. Only one angle needed in this formula. And the reason I tell you to memorize this one is whatever a triangle is, we can always rename it. I could all of a sudden call this side A. I could call this side C, and I could call this side B, right? It doesn't really matter what we name it. So what we do is, if cosine law either solves for an angle or a side. And in fact, they have to be opposite of each other, the two that we're solving for. So I suggest just renaming all of your triangles. If you're looking for, say this was the side you're looking for, you name that C, which would make this angle C. See? That would make this angle C. Okay? And then the A and the B are important, but not as important angle-wise. If this is the angle you're looking for, this one here, well, luckily it's already called C, so this must be called side C. And let's say we were looking for this angle here. Well, we rename it C, and then we rename this side C, and then change it around. That way you only have to memorize one formula. Okay? So now that we have that information, I have a triangle here, and they want us to solve. In other words, solve every piece of this triangle. So, first thing I'm going to do is I'm going to work with this. I'm going to say I want to solve this angle first, and they usually refer to an angle as theta. Okay, well, I'm going to need to name this triangle. And since I need this angle, just for cosine law's sake, I'm going to call this angle C, which would make this side C. And then we're just going to name the others. We'll call this B, which makes this angle B. And this will be side A, which makes this angle A. Does that make sense so far? Okay. Now, let's plug in all of our information. For sine law, well, it's sine angle A. Well, I don't know what that is. Divided by side A, that's 26, is equal to sine angle B. We don't know what that is. Side B is 55. Is equal to sine angle C. We still don't know what that is. We called it theta. And side C is 32. Well, if you look at sine law, I don't have one complete ratio. And in order to use sine law, I must have at least one complete set of ratios. I must have an opposite side and angle. I don't have that, which means I can't use sine law to solve this. I have to use cosine law. Now, because this is the angle I was looking for, I can use that specific cosine law I told you about, the one where we use angle C on the side. So C squared is equal to A squared plus B squared minus 2AB cos C. Well, it just so happens C is our theta. That's what we're looking for. So side C is 32. So 32 squared is equal to side A was 26 squared. Side B was 55, so 55 squared. Minus 2 times 26 times 55. Times cos, and C is our theta in this case. So we're looking for that. Okay? Well, we go through this quickly. I'm going to get you to get a calculator out too, maybe to help me out. 32 squared, 1,024. Okay? 26 squared, 676. 55 squared, 3025. Okay. Now this is technically, think of it like a -2. So -2 times these values. Well, we know we're going to get a negative value because it's a negative times a positive times a positive. So we're going to get negative something, and I'm just going to go 2 times 26 times 55. So 2 times 26 times 55. 2,860. And think of it like it's a negative value. Times cosine. Now this is where many people make errors. They simplify this side by putting all three of these terms together, but that can't be done. Because technically this is multiplied by, and according to BEDMAS, I have to multiply this first. So the only two terms I can actually put together are those two. Okay? I can't just all of a sudden put that other one there. So we get 1,024 is equal to, let me go to simplify here, 676 plus 3025, 3701. 3701 subtract 2860 cosine. I still can't do anything with that. Well, first I'm going to move this guy to the other side, which will give us 1,024 minus 3,701 is equal to negative 2860 cos angle C, or theta. Then we'll get 1024 minus 3701, negative 2677 is equal to negative 2860. And remember, the idea here is to get theta by itself. We're trying to isolate our theta. So the next step is I'm going to divide. Because this is multiplied by, I'm going to divide both sides by the negative 2860, which means they'll cancel out or create a 1 on this side here. And when we divide those values, divided by 2860 negative value is equal to positive 0.936, let's say. 0.936 is equal to cos theta. Well, we got to get theta by itself. So when I move cos over, it becomes cos inverse of this term, theta, which equals theta. So the angle, I do inverse of this, inverse cos, 20.6, 6 degrees. So, let's jump back up to a triangle. This angle here is 20.6 degrees. Great. I want you to notice cosine, if you look at it, it takes a bit to do. It's quite a long process there. Well, now that I have this, what I have is, if you'll notice, a complete ratio. I have an opposite. So now I can jump into using sine law. And sine law is a little quicker when we go through it. So I actually have the complete C part of the ratio. We know this theta is now 20.6. And let's say we want to find angle A now. So we have sine A divide 26 is equal to sine, still don't know B, over 55. But we do know angle C. Sine 20.6 divided by 32. Now with sine law, we only need 2 in the ratio. And since we're looking for A, we're just going to drop that middle ratio off. We don't need it. So we're left with sine A divided by 26. I'm just going to pause this for a sec. Okay, sine A equals 26 is equal to sine 20.6 over 32. Well, same idea. We're still trying to get angle A in this case. So what I'm going to do is I'm going to bring 26 over. And when I bring it over, I don't know, we're running out of room. I'm going to try to squeeze it in here. Sine A is equal to sine 20.6 multiplied by 26. And all of that is divided by 32. Okay? So I'm going to figure that all out right now before I do anything else. So let's clear this. 20.6 sine gives us that value times 26 divide 32.285, let's say. 0.285 is equal to sine A. And how do I get A by itself? What will I need to do? Move. Yeah. So it becomes sine inverse. Sine inverse again. And in this example, we'll realize that we've only been solving angles. Okay? So since we have sine inverse there, we have that value. We now do sine inverse of it. So inverse of sine, 16.6. So angle A, 16.6. So So this is 16.6. So we found two of them. We use sine law, we use cosine law. I got to find angle B. I could use sine law again. I could use cosine law again. But because I have two angles, there's a really fast way of doing this. What do all the angles in a triangle add up to? Yeah. So I take 180 and just subtract those two values. 20.6 and 16.6. That's going to give us our angle B. So we'll get our calculator out here. 180 subtract 20.6 minus 16.6, 142.8. And that makes sense. That's an obtuse angle, 142.8. So this is 142.8. So we've used cosine and sine law to help solve this question. I could have just only used cosine law, right? But once we use cosine law, sine law is a little faster if you notice. It's nicer to start using easier and easier things. This would be the most efficient way of using them in tandem with each other.